Let's look at some formula solving. This is where we solve for a specific variable. In this problem, we want to solve for the a. That means that we want to isolate the a. We want to get the a all by itself. To do that, we go on the side with the a, and we get rid of any other term that's on that side. So here is our a. The other piece that's on that side of the equal sign is the b. So we would like to make the b cancel. The b is added to the a term, so to take it off, we should subtract it from both sides. This is what we had. We're going to take it away. Do the same on the other side. Clean up. That leaves only your a on the left. C minus b, there's nothing you can do there, but you have met your goal. You have isolated the a. The regular equation that this is similar to is one that is only a one-step solve, like x plus 5 equals 7. Rather than just looking and saying, okay, x is 2, if we go through the process, we go on the side with the x and we take off anything added or subtracted. So 5 is added, we should take it away. Do the same to both sides. Clean up. X is isolated. That's our goal. Exact same step here. We wanted the a, go on that side. Take off anything added or subtracted, so we want to take off the b. It's added, so we must take it away. From both sides, clean up, the b cancels, leaves only the a. The other side we can't do anything because they're not like terms, but we have met our goal, which was to isolate the a. Just a quick note here, if you're used to solving equations and you normally work vertically, like if you wanted to take the b off and you subtract, if you try to write it under, you get in a bit of trouble with formulas because when you go to the other side, you don't have like terms. So I would recommend the horizontal notation. If you're going to work vertically, don't put it under the c. You're going to need to put it over because they're not like terms. So I would recommend the horizontal notation for formula solving. Let's look at another problem. This one is solve for a, and we have a minus b equals c. So first we would go on the side of the one that we want. So we're going to go on the side with the a. We look around and anything else that's there we want to get rid of. So we want to get rid of the b. We want to notice that the b is subtracted from the a. So to make that cancel, we should add. Just like equations, so this is what we had. We'll add a b. On the left, it cancels. Leaves us just a. And c plus b, there's nothing you can do because they're not like terms. You have isolated the a. That was your goal. Let's look at this problem. Solve for p. We have p times b equals a. So first of all, go on the side of the one that you want. So go on the side with the p. Whatever else is there needs to come off. So we want to take off the b. What is the relationship between the p and the b? They're multiplied. So to reverse a multiplication, we should do a division, and we're going to divide out the part that we don't want. So we're going to divide by the b because we want to get rid of it. Do the same on both sides. On the left it cancels to leave us just p. And on the right you get a fraction, but that's okay. Your p is isolated. That was our goal. This is still a one-step solve problem. It works very much like this regular linear equation. 3x equals 12. To isolate the x, you go on that side. You get rid of whatever else is with the x. So you get rid of the 3. The 3 is multiplied by x, so to get rid of it, you divide. You're dividing out the part you don't want. And that leaves you x equals 4, so your x is isolated. Exactly the same here, except you're isolating the p. Let's look at this problem. Solve for m. So m is what we want to isolate. We should go on that side. So we have F equals m times a. Force equals mass times acceleration. But we don't really care about that here. What we care about is getting the m all by itself. So we need to work on the side with the m. We want to keep the m, so we want to get rid of whatever else is on that side. We want to get rid of the a. What's the operation between the m and the a? They're side by side, so they're multiplied. To reverse a multiplication, you need to divide. We're going to divide by the piece we want to get rid of. So we're going to divide on both sides by the a. Now, there's nothing we can do on the left-hand side, but the m is now isolated. That was our goal. Before we solve our next formula, I want to go back to a linear equation. 3x plus 5 equals 11. This is a nice standard two-step equation. We would want to solve for x. So we would go on the side with the x, and we would take off anything added or subtracted. So we would take off the 5. So we have 3x. That's what we had, and we would subtract our 5 from both sides. Clean up. We would have 3x equals 6. Now go back on the side with your variable, and you divide out your coefficient. Get x equals 2. Formulas work the same way. It's the exact same steps, except you're told which one to isolate. So on this particular formula, we're going to isolate the x. So we're going to go on the side with the x. We want the x. Look around the x. Notice the x is multiplied by the 5, so we'll leave that till last. The other piece on there that we want to take off is the f. So we will take the f off first. Anything added or subtracted should come off first. So if it's added, we're going to subtract it from both sides. Clean up. Nothing you can do on the right-hand side. Those are not like terms. Just bring them down. Now go back on the side of the one you want. You want the x, so you should be on that side. The piece that's left with it is the 5. It's multiplied, so to get that off, you're going to divide. You can divide on both sides by the 5. On this side, just do it under the whole piece. Clean up. Your 5 cancels. Nothing you can do on the right-hand side, just leave it. And x is isolated. That was your goal. Next we have a two-step solve problem. We want to solve for t. So we're going to go on the side with the t, find the t. That's what we want to keep. So we look around the t. Notice the t is right beside the g, so they are multiplied. We'll leave that till last. Take off anything first that's added or subtracted to your t term. So the k should come off first. Now we want to make the k cancel. That's a positive k, so we're going to need to subtract it from both sides. You should write it at the end. Don't write it in front of the v. You'll mess up the sign. So we're going to subtract a k from both sides. We'll cancel on the right. Nothing we can do here. They're not like terms. Now go back on the side of the one you want. We want the t, so we're looking on that side. Whatever else is there is what we want to get rid of. So we want to get rid of the G. The G is multiplied, so to take it off, we will divide. So we're going to divide on both sides by the G. Now, there's nothing you can do on the left because these are not like terms, so we'll just leave that. It's okay that it's a fraction. On the right-hand side, the G's cancel. T is isolated. That was our goal. Let's look at one more problem to solve for a variable. We will solve for the R. And so we'll always go on the side and find our variable that we want. So here's our R. The one right beside it, the I squared, is multiplied by the R. Other things on that side, we have a 10 that's added. You always take off first anything added or subtracted to the term you want. So we're going to get rid of this 10. It's added, so we're going to subtract it from both sides. Clean up. There's nothing you can do on the left. These are not like terms. Your 10 cancels on the right. That was our plan. Right, now go back on the side of the one you want. So you want the R, you need to be on that side. The only thing left we have to get rid of is the I squared. Notice it's multiplied by the R. So to get it off, we will divide. We're going to divide on both sides by I squared. We'll cancel on the right. On the left, you're just going to leave it. There's nothing you can simplify there. So you have P minus 10 over I squared equals R. We're going to look at formulas that contain fractions. Just like with equations, we want to clear the fractions out of formulas if we are solving for a specific variable. I have put up 4 different problems, and I wanted you to be able to compare them and see the difference. For all of these, we need to clear out the fraction. In the first one, our common denominator is going to be 2, so we're going to multiply on both sides by 2. What's important on this one to see is that on the right-hand side, the half BH is all one term. To be separate terms, it has to have plus or minus in between. So when you multiply by 2 on this problem, you're going to do it on the side with the A and just at the front times the half. The second problem, notice the sign in between the pieces. This makes separate terms. So you will pick your common denominator on this problem, looks like a 6, and you'll do 6 on each term. So you'll do a 6 with the first piece, and the plus starts the next term, so you'll do a 6 there and also on the other side. The third formula that we have, 2 is going to be our common denominator, and we're going to multiply on both sides by 2. On the right, this fraction is just all one piece, so you'll just do the 2 at the front. Also, this one brings in another situation. It has a capital variable and a lowercase variable. You are never going to combine these. Just treat them like an X and a Y. And our fourth situation we're going to look at with a formula with a fraction is the one they're asking for is currently in the denominator. We cannot solve for it in the denominator, so we have to take it out of that denominator before we can solve for it. On our first formula, we want to solve for B. A equals a half BH. We want to isolate the B. The first thing we will do, though, is to clear out the fraction. So our common denominator is a 2. We're going to multiply on both sides by the 2. And then we'll clean up. So on the left, we're going to have 2A. On the right, these will cancel, so we'll be left with BH. Now we'll look to see. We're trying to solve for the B, so we will go on the side with the B. On the side with the B, there is also an H, so we want to get rid of the H. Notice they're side by side, so they're multiplied. To reverse a multiplication, you will divide. We're going to divide out the one that we don't want. We want the B, so we don't want the H. So we're going to divide on both sides by the H. H will cancel on this side. On the left, 2A over H equals B. We've isolated B. That was our goal. For our next formula problem, we are going to solve for x. This is the one that looks the most like an equation. So we want to isolate the x. Our first thing, though, we will clear out the fraction. So for our common denominator, we're going to need a 6. Remember, the 7 is over a 1. So 6 would work for 3 and 2. So we're going to multiply everything by a 6. You have to do both sides for this to be okay. And now we're going to clean it up. So this is really 6 over 1. On your diagonal, your 2 is going to divide out. 2 will go into 2 once and into 6 3 times. So we have 3 times 5x gives us 15x. On the next term, our 3 will go into 3 once, and into 6 it will go 2 times. And 2 times 4y will give us 8y. And this side, since there is no fraction, we will just multiply. Right, now we want to isolate the x. So go on the side with the x. Notice x is here. 15 is multiplied by the x, so we'll leave that till last. You want to divide last. Take off anything added or subtracted. So our 8y is added to the x term. We're going to take it off first. To do that, we should subtract because we want the entire piece to cancel. So keep the 15x, and this is what we have, and we're going to take 8y away. It will wipe out. Do the same thing on the other side. Clean up. So we're left with 15x equals 42 minus 8y. Now, remember which one you're trying to get to. We're trying to get to the x. So go back on the side with the x. Now you're ready to divide by 15. So we're going to divide across by 15. 15 here. With formulas, you just do it under the entire piece. On the left, these will cancel out. So we're left with x equals. On the right-hand side, you're not allowed to divide anything out there. Even though the 42 and 15 have a common factor of 3, you can't divide that out because the 3 doesn't go into 8y. So we're just going to leave that piece as 42 minus 8y over 15. Our x is isolated. That was our goal. For our next formula, we're going to solve for p. Our first thing we're going to do is clear the fraction. So our common denominator is a 2. We're going to multiply on both sides by 2. On the left, we'll just do 2 times q. And on the right, we're just going to do it at the front of that problem. So we'll clean up. And on the left, we have just 2q. On the right-hand side, our 2's canceled to leave us p minus q. Now, look back and see which one you want. We want the p. So go on the side with the p, and that means you don't want that small q. So we're going to get rid of this q. Notice the operation between it and the p. It is subtracted from the p, so to make it cancel, we need to add this small q to both sides. So on the left-hand side, this is what we had already, and we're going to add a small q. On the right-hand side, this is what we had, and we're going to add a small q. Doing that to make this one cancel. When we clean up, remember on the left, you're not allowed to put the capital and lowercase variables together. They can stay on the same side, but they cannot combine. We have isolated the p. That was our goal. For our next formula, the variable that we want, the c, is in the denominator. So first we have to get it out of the denominator. We will do that the same way we would clear a fraction. So our common denominator would be a c. We're going to multiply on both sides by c. So we'll do a c on the left. And here we will also do a c. We'll clean up. Here we're left with CP, or you could have put PC. It's the same. On the right-hand side, these will cancel to give us AB. Now we don't have a fraction anymore. Look on the side of the one you want. You want the C. So we're over here. Anything else is there you want to cancel. So we want the P to cancel out. Notice the operation between the P and the C. They're side by side, so they're multiplied. To reverse a multiplication, we're going to divide, and we're going to divide out this P. That's the part we don't want. Do it on both sides. Cancels on the left to give us C, and nothing we can do on the right side. We just leave it as a fraction. But we have solved for P, and it is no longer in the denominator. We're going to look at one more formula. This one we're going to solve for V2, and it does have a fraction to clear. When you have subscripts, you will not combine those. This is often used in science, but as far as manipulating the formula, treat it just like an X and a Y. V2 and V1 will never go together. So first of all, we're going to clear the fraction. The common denominator would be a T, so we're going to multiply by T on both sides. And just at the beginning of that fraction, we will clean up. On the left, we have TA or AT, doesn't matter. On the right-hand side, that T has canceled out our denominator, so we have V2 minus V1. Right, look back to see which one you want. We want the V2, so go on the side with that one. We want V2, so that means we don't want this V1. It's subtracted from the V2. So to make it cancel, we should add a V1 to both sides. So on the left, this is what we had, TA. We're going to add a V1. On the right, this is what we had. And we'll add our V1, which will cancel. Nothing we can do on this side. They're not like terms. And on the right-hand side, we have our V2 isolated. That was our goal. Formulas that contain parentheses. For formulas that contain parentheses, you must stop and think before distributing. If the variable that you are solving for is inside the parentheses, distribute. If the variable you are solving for is on the outside of the parentheses, do not distribute. We're going to solve the following formula twice. The first time we will solve for x, and you will notice that x is on the inside of the parentheses. The second time we will solve for h, and you will notice that h is on the outside of the parentheses. So first, let's solve for the x. X is on the inside of the parentheses, so we should distribute because we want to get it out of the parentheses. So we'll distribute the h. So we have 2a equals hx plus hy. Now, you want to work on the side of the variable that you're looking for. You're trying to get to the x, so go on that side. Notice the h is right beside it, so they're multiplied. You'll deal with that last. First, take off anything added or subtracted to the x term. So we're going to need to take off the hy term. It is added to the x term, so we'll need to subtract it from both sides. So first we'll subtract the hy from the left. Then we'll subtract it from the right. It will cancel. That was our plan. We'll clean up. Now we'll go back on the side of the variable we want. We want the x, so we're on the right-hand side with the x. The only thing we have left to get rid of is the h. Notice the h is multiplied by the x, so to get it off, we'll need to divide. We'll divide it on both sides. On the right-hand side, it's just going to cancel out to leave us x. On the left-hand side, there's nothing that we can do. We're not allowed to cancel out the h because there's not an h in both terms in the numerator. So we have to just leave it. We have isolated the x. Now we'll work on the same formula, but this time we're going to solve for h. And notice that your h is on the outside of the parentheses, so you will not distribute. If you did distribute, you're going to get the h in two places, so you would not be able to isolate it. So if we can't distribute, let's think about how we could get the h by itself. Notice the h is right beside the parentheses. What's the operation if the h is right beside the parentheses? It's a multiplication. To get rid of a multiplication, you would divide. So you can actually divide right here by the x plus y. That's the piece that you don't want. So we'll just divide out that big chunk in one step on both sides. Will disappear from here. And this one is actually done. It's easier than the other one. Our h is isolated. So remember, if the variable you want is on the outside of the parentheses, don't distribute. Let's look at another problem. For the first one, we are going to solve for w. We notice that we have parentheses, so we ask ourselves, is the w on the inside or the outside? It is on the inside, so we will need to distribute to get it out of the parentheses. So we will distribute our b, and this would give us b3, or 3b is a more common way to see that, plus 2bw equals 25. Now, we have to go on the side of the one we want. Remember, we want w, so we're working on that side. Look beside the w, the 2 and the b are multiplied by the w. So we'll leave those till last, but we're going to work on that side. So anything else on that side, which is our 3b, we're going to take off first. It's added to the w term, so we're going to need to take it away on both sides. So we're going to subtract a 3b. It will cancel on this side. That's our plan. And we'll also have to take it away on the other side. This will go out. We'll clean up. So we have 2bw equals 25 minus 3b. Now go back on the side of the variable that you want. You want the w, so you're working on that side. The 2 and b are multiplied by the w. To take them off, you're going to divide. Do the same on both sides. And we'll clean up. On the right-hand side, you're not allowed to divide out the b. It is not in the first term. If there's any sign in between, you cannot take a piece out. So let's clean it up. We have w on the left equals 25 minus 3b divided by 2b. But our w is isolated. That was our goal. We'll look at the problem again, but this time we're going to solve for B. And notice your B is on the outside of the parentheses, so don't distribute. If you distribute, you'll have it in two places and you can't isolate. So to get the B by itself, if it's outside, notice it's multiplied by the parentheses. To get that off, you would divide out that entire piece in one shot. Clean up. On the left, we have B by itself, and there's nothing we can do on the right-hand side. We'll just leave it.